Okay, so for this example, we've got this diagram. To get the reaction forces, we can take 4 kilonewtons per meter times 2 meters. That would be 8 kilonewtons acting at 1 meter from the right side. So let's go down. Next slide. Oops. Let me expand this a bit. Get into our slideshow mode. Come on. There we go. And note this. W is a negative constant now. So dV dx is negative 4 kilonewtons per meter. Slope here is, for the right portion here, 0. Find the reaction forces just like we've done before. And okay. So we can go on to the next one. And it's just the reaction forces. The reaction force here would be negative 2 kilonewtons. We have a step up to 8 kilonewtons and then a gradual step down. So that's what's going on. Negative 2, we step up by 10, which would mean it rises to a positive 8, and then slopes downward to the end at x equals 6 meters. Is that? Yeah, at x equals 6 meters. So now dm dx equals v. So you're going to have a linear dm dx. The slope is going to be negative 2. Negative 2 times 4 is negative 8. So that's the maximum moment. And then you're going to have parabolic from here on out. And you'd have to figure that out. Yeah, just like I did before, you have a slope here. So you would have a linear equation that you'd have to integrate to get the m, and it is quadratic because it'd be mx plus b, while the integral of x is x squared. So you know this is going to be quadratic. Okay. Cables. So we're going to talk about cables next. I'm not going to get too deeply into this, except to go through a general procedure. So we have point loads and distributed loads on cables. We'll talk about distributed loads a little later. Here's the point load thing. Lots of equations, lots of unknowns with the point loads. So you're going to know the lengths, you're going to know the forces exerted. So you have this many knowns. See, 1, 2, 3, 4, 5, 6, 7. You have 9 unknowns, which are the tensions in the 3 pieces, the displacement here in the middle, and the reaction forces. Oops, instead of D, that's supposed to be B's. Okay. 8 equations. You don't have enough equations. So you have the x and y forces at A, B, C, and D. So that's 2 dimensions, 2 times 1, 2, 3, 4, 8 equations, 9 unknowns. Need more information. Difficult to solve. Strongly recommend some sort of computer tool to work on problems of this nature. So here's an example. Now, we said earlier 9 unknowns, 8 equations. So we're given one unknown. Yay! So that allows us to zero in on the equations. And we look at it like the method of joints. What is happening at each point? So the overall reaction, AY plus EY has to equal the sum of these three, and AX and EX have to equal 0. Summation of forces equals 0. And how many equations and how many unknowns do we have? So we had 1, 2, 3, 4, 5. This time we have 10 equations and all the unknowns, the tensions. So we would have 4 tensions. 1, 2, 3, 4. 10 equations, 4 unknowns, 2 here. So that's 6 unknowns. And then the reaction forces. Add 4 more. So 10 equations, 10 unknowns. So we have this going on, and okay, here we go. I did make a mistake. I did misstate something earlier, that AX and EX are not equal to 0 because we have some things, we have forces in the X direction due to these tensions. So using your overall reactions, this would be your overall reactions. You can get the vertical components of the forces. And here you get an equation in AX and EX. But we got to consider this first. Moment about M sub C has to equal 0. So T, this tension would not influence that moment. Let's see, go back a second. There it is. C is right here. There's a tension right down here. And that tension would have no influence on the moment about C. So we can look at AX independently. We've already found AY. So that lets us get at AX and EX. So we can write this down. Now, after that, we can start looking at, now that we know this from the moment equation, we can get the force, sum of the forces in the X direction. Well, TBC cosine theta BC has to equal AX. And forces in the Y direction, TBC sine theta plus 4 kilonewtons has to equal 12. So between these two, you can get the angle and the tensions, and you can work through the rest of the problem the same way. Okay. So I wanted to go through an outline of how to do a problem like this. And watch out for the number of equations and the number of unknowns. So then you can find the maximum cable tension. In general, these problems are hard. Lots of equations, lots of unknowns. So, like I said, I'm not going to spend much time on it. Too tedious. And I don't think you have any of those in the homework. If you do, skip them. That's okay. If I made a mistake and left some of that in the homework, go ahead and skip that. Okay. Now, cables under distributed loads. I'm going to end the video here, and we'll pick up this with the next video.